Good evening, Sir Veles. So my name is John Greg Villarreal, and here is my final output in educational statistics. So I'm going to show you the on how to use the SPSS. Okay, first we have the problem: data scores of 10 students on two entrance test, which is test 1 in English and the test 2 is on Filipino. So we're going to determine the degree of relationship between the two tests and provide a short discussion or interpretation of the result. So I already opened my SPSS, and I already gathered all the variables, and I already uh, put it in the on the SPSS. So it's already here, and we have the data view also. So we have test 1 and test 2. This data, the test 1 and test 2, are from the problem. Okay, so now we're going to analyze, or we're going to get the persons for this data. So since I already gathered all the necessary, especially the variables, so since I already gathered it, so I can now I am now able to get the result for the persons are. So I'm going uh, to click analyze, and then I'm going to select correlate, and then by rate, and then test 1 and test 2 is already in the variables, and then the correlation coefficients is persons or person, since I'm going to the problem is looking for the persons. So the test of significance is two-tailed, and then click OK. So therefore, the result of these two tests, test 1 and test 2, is significant, or the correlation. Okay, now let's proceed to getting the chi-square. Okay, so we have the problem. A researcher is interested whether there is a significant relationship between gender and the educational attainment of the respondents. To investigate the issue, the researcher randomly selected 25 teachers and noted their gender and educational attainment. So gender, we have 1 for male, 2 for female, and for the educational attainment, we have 1 for BA/BS degree holder, 2 for MA/MS with units, and 3 for MA/MS degree holder. So the respondent is 25, as shows here in the given in the problem, and we have gender and the educational attainment as well. So we're going to put the data in the SPSS. So I already put it here already in the SPSS. The respondents, the first column is for the respondents, second is for the gender, and the third one is for the educational attainment. So now let's proceed to variable view. I already also put in the respondent and the gender and the educational attainment on the names, and then also the label. I already copied it. Respondents, of course, the label is still respondent. Gender, and we have gender, educational attainment, but the values are, we're going to change it. So since we have gender, we have coded 1 for male and coded 2 for female, so we need to change that. And yeah, it shows here already that it's already coded, since I already put it there already. Okay, and then we have educational attainment. So we have 1 for BA/BS degree holder, and 2 for MA/MS with units, and we have MA/MS degree holder. Okay, so I already changed the measure on this column. So I already select nominal. Okay, and then the decimal, I already changed it to 0. Or in the data view, we can saw here that 1 is for male, female, 2 for female. And then the corresponding codes for the educational attainment. Okay? Next, after that, since we already gathered the data and already put all the necessary variables, so we're now going to analyze it. So click descriptive and then cross tab. Okay? So after the cross tab, so I already put the rows, the gender on the rows, columns for educational attainment, and the next layer is for the respondent. So this time, we're going to select chi-square. So click statistic and then click chi-square and then continue. Okay, so exact. Okay, so continue, just continue. And then, okay, so since already all set, so we are now click OK. And then wait for the result. Okay, so this are the result for chi-square. So therefore, we can say that sa gender, we have male 4, for BA, BS degree holder, educational attainment is 2, MAMS degree is 3, total of 9. For female, we have 1 for BS, BA degree holder, educational attainment with units is 5, and 10 for MAMS degree holder, 10. So total of 16. So 9 plus 16 is 25. So it shows that the respondents are equal. So we have 9 and 16 for male, male and female is 16. So total of 25. And the next columns or the next graphs are showing for the respondents, the results of the respondents. Okay, and then so we have letter A for 5 cells, 83.3 have expected count less than 5. The minimum expected count is 1.80. No statistic are computed because gender and educational attainment is constant. Okay, so these are the needed data for and getting the chi-square. Okay, thank you. Next is for the we're going to get the t-test. Okay, okay, now let's proceed to Way Anova. So we have the problem here that a researcher is interested whether teachers' employment status differ in a relation to teaching performance. To investigate this, researcher selected 24 teachers in each type of employment status and measure their teaching performance. The data shown below, teachers are coded 1 if they are part-timer, 2 for the temporary teacher, and 3 for the permanent teacher. So we're going to determine if there are significant difference on the performances of the teacher when their employment status is considered and discuss it in briefly result. Okay? So we have the given case. Okay, so we have 24 selected teacher, employment status, and the teaching performance. So I already put in all the necessary datas in data view. So I already put the case, employment, and the teaching performance. But before that, so you need to put all the variables that you needed. Okay, so case, employment status, and the teaching performance. So I already changed the decimals to 0 and then change the employment status to the values of it. So we have part-time for 1 or code 1, 2 for temporary, and 3 for permanent. Okay, and then after that, so I select measure for nominal, and then yeah, I need to align it center. Okay, so after that, you can now analyze the data. Okay, so you need to select Bayesian statistic. Okay, and then select Way Anova, and then all the variables, or we have 3 variables: the case, employment status, and the teaching performance. So I already put the case and the dependent dependent factor for employment status and weight for teaching performance. And then so criteria is 95% and then select OK. So therefore, yeah, we have the result, and then shows that A is for the dependent variable case, modal for employment status and regression weight, C for regression weight variable teaching performance, and assume standard reference values. So therefore, it shows here the mode and the mean, okay, for posterior, and we have 95% credible interval, so we have for the lower bound and the upper bound, okay. So we have also, or it shows also here on the bottom part, the Bayesian estimate for error variance. So we have for mode 411 3.516, mean 4979.519, and variance 2917130.505. And then we have for 95 credible interval. So for lower bound we have 2666.681, and for upper bound we have 9200798. Okay, so letter A is for assume standard reference value. So this is for one-way ANOVA. Okay, and now let's proceed to t-test. And now let's proceed to t-test. Okay, so let us have first the problem. A researcher is interested whether there is a significant difference in the teaching performance of male and female teachers. So the researchers randomly selected 24 teachers, noted their gender, and evaluated their teaching performance. Gender is coded 1 for male, 2 for female, and the data shown below. Okay? Determine the significant difference between the teaching performances of male and female using the independent sample t-test. Okay? And then discuss, interpret briefly, and the results. So we already have the data here, the case, gender, and teaching performance. So I already also prepared in the SPSS in the variable view. So I already prepared the case, gender, and teaching performance. So I already changed only the gender since we have 1 for male, 2 for female. Okay, and then I already changed the alignment to center, and the measure is for nominal and 0 for decimal. So now let's proceed to the data view. So we have case, gender, and teaching performance. So we can show here that the male and females are represented by 1 and 2 since we already changed it to the variables. Okay, so now let's proceed to get and analyze using the t-test. So we have to go to compare means and independent sample t-test since this is the what the problems are asking for. Okay, so we have teaching performance for the test variables and gender for grouping variables. Okay, so we're going to define it for group 1 we have 1, group 2 is for 2, which is the male and female. Okay, so now let's proceed to the options are still 95, that's the common. We're not going to change that, and then okay, so for us to check the t-test. Okay, so we have now the result for t-test group statistics. So we, in terms of teaching performance for male and female, we have for the mean of 93.74 the male, and female for 82.64. Okay, and then we have the independent sample t-test showing that we have the mean difference the same, and to the error difference, or for the standard error difference, we have for the male we have for equal variance is assumed, so we have 1.162, and for equal variance is not assumed, we have 1.203. Okay, so for the 95% confidence interval of the difference for the lower and upper, so we have 8.647 And we have 8.519. We have for upper, we have 13.467 and 13.595. Okay, so these are the results for the t-test. Okay, and now these are all the summaries for my report, and I already showed to you and explained to you how to get the persons and using the person, chi-square t-test, and one-way ANOVA using the SPSS. I hope you learned something, and thank you for watching. Bye! Thank you! Bye, sir!